Hello friends, welcome to the VHDL design course. So today we are going to start our new topic, that is the test benches. So till now we have seen the various concept of digital design, then advanced digital design concept, then sequential VHDL sequential circuit. Then we have seen various writing a VHDL program with the combination circuit as well as sequential circuit. Then we have covered the various projects. So till now I hope we have covered almost complete VHDL concept. Now the point came, now to verify these designs we need some kind of test benches. Okay, so in this topic we will try to cover how to write VHDL code for test bench, how to verify the design using the test benches. So we are going to cover combination circuit test benches as well as the sequential circuit test benches. So let's begin. So before starting the test benches, so what is the test bench? Okay, so first of all we need to understand the test bench. So till now we have written a various VHDL code for various examples. For example, in combination circuit we have written a code for multiplexer, demultiplexer. We have written a code for let us say example counters. Then we have also written code for 7-segment decoder. Then we can say sequential circuit like sequence detector. Now that time we what we are doing, we are just going into the simulation waveform, and each and every signal we are forcing and checking it. But this is not the applicable when we are designing a very huge design. Let us say in a huge design we have let us say 100 number of inputs and some 50 numbers of outputs. So this is may not be possible to verify using the waveform or normal method. So for that we need to write a separate VHDL code to verify that design. So that's what in VHDL test bench plays a very important, as well as in VLSI it plays a very important role. So as I said in my earlier video where I explained the job opportunities in the VLSI. So this is one of the very huge requirement in India, where people has to do a lot kind of verification. So all the verification jobs come under this test benches. Okay. So what is a test bench? So VHDL test bench is a piece of VHDL code which purpose is to verify the functional correctness of our HDL model. So whatever the design we are writing in a VHDL, so that is verified by using these test benches. So what are the main objective of test benches? The main objective of test bench is to instantiate the design under test. So whatever the model we have written in a VHDL, or that model we wanted to test it, that first of all you have to call in our test bench. So if you go back and see how structural modeling work, here also the same concept, that model we are calling in the test bench, and then inside the test bench we are assigning the value tag to that design under test, or we call as a DUT. So first thing is instantiate the DUT, then second generate the stimulus waveform for the DUT, then generate the reference output and compare them with the output of the DUT. So we have to create the various test cases as per the DUT specification, design under test specification. Okay, then generate the reference output, also expect what is the my expected output, then compare it with the our design under test output. So that can be done inside the test bench, and it gives automatically provides a pass or fail indication whether our design is pass or fail. So it simplifies the our work. Okay, so test bench is a part of a circuit specification. It is a good idea to design a test bench before the design under test. Usually we'll get a specification for design. So similarly, parallelly, whenever design is going on, that time also we can start our test bench writing, or verification test cases we can start building. So this is a parallel process with design as well as the test benches. So how it looks like? So if you see in this diagram, so in the test bench, if you see here, the test bench, this is our design under test. So test bench doesn't have any external input and output, please remember. test bench has only internal signal. Test bench has only internal signals. Okay, so what the test bench does, the test bench display the values on terminal. Okay, so whatever the result or the output values can be displayed on the terminal, verify the results on waveform, and test bench checks for the correctness. So it will check the correctness of our design. So usually test bench architecture is like this: the design under test. So the design under test has its internal signals. Okay, internal and output, input and output, and around that we are building this test bench. Okay, we are building this test bench. So these internal signals, inputs of the DUT, are connected internally by the test bench, and these signals we are assigning as a test cases. Okay, and once these outputs are available, we can compare this output with expected output, and accordingly will give a severity result. Okay, so we are going to see these examples in future. So this is a general architecture of the test bench. So inside the test bench, DUT will be there, and outside the DUT, test bench wrapper will be there. Okay, now to test a circuit, we will design another circuit. Okay, so to test one of the circuit, we need to design another circuit which will generate the signals required to test our circuit. Interestingly, this circuit also we are going to write using a VHDL. Okay, so if you remember, the first VHDL language, the generated for this simulation purpose only. So first intention to design a VHDL language is for this simulation purpose. So that's what, whatever the VHDL language, we can say constraints or parameters or data type objects, all are perfectly suitable for the simulation. So we might have seen in the synthesis some of the data types are not supported by the synthesis tool. So that is the reason initially VHDL was developed while keeping in mind that for the simulation purpose of the circuits. So later on, then it is shifted for the design of the hardware also. Okay, so that's what, if you compare the synthesis and simulation, in synthesis all the data types, all the parameters of the VHDL are not supported in synthesis. For example, time. Okay, time is a data type, physical data type, that is not supported for the synthesis, but it is supported, it is fully supported in the simulation. So please remember, for simulation all the parameters are supported, but for synthesis some of the parameters are not supported to generate a gate level netlist. Okay, since the test benches are used for the simulation purpose only, not for the synthesis, therefore all full range of VHDL constructs can be used. So that's what I told, all the constructs are accepted or supported by the simulation. Okay, and that makes the simulation more rigorous, and we have lot of options to write various test benches. So I will give a small short example of how to write a test bench. So let us take an example of XOR gate. So let us say we have to verify this design. So as I said, in test benches we have to do three steps. First of all, we have to call the design under test, that is instantiation, then generate internal signals and give the stimulus to that internal signals. So let's begin. So let us take an example. This is the XOR gate, right? This is the XOR gate. So XOR gate has two inputs. This is one input. So let us say in 1, input 2, and this is output 2. So this is the DUT. This is our design under test. So this we have to call inside the test bench. But in the test bench, we have to declare another internal signals to assign the values to this, and whatever the output we are getting, there also we need to declare one more signal. Now to start the test bench, library declaration will be same. But if you see the entity, there is no port list in the test bench. Please remember. So entity, to start with the name entity, my XOR gate test bench is. Okay, so we are generating one test but empty entity. So there is no port list. Okay, then end my XOR gate test bench. Okay, so first of all, whenever we are declaring the entity for test bench, there is no entity part. Okay, Now here comes the test bench declaration. Now we'll see how to write a test bench for the XOR gate. Okay. So our test entity declaration is done. So it is a empty entity. Then architecture, same declaration. Architecture name of test entity name is, then component. So here we are calling as that our DUT. So our DUT is my XOR gate. So for XOR gate we have input 1. So its signal integration is like this: input 1, input 2, and we have output 1. Okay. So this DUT we are calling here, instantiation we are doing here, you are calling here that component. So input 1, input 2, output 1. So once that is done, then we need to declare some of the internal signal like input 1 signal, input 2 signal, and output 1 signal. So that signals we are declaring here. Okay. So that signals we need to assign the values. So after declaring the component, we need to declare the signal. So the signals we have to declare. Then we have to start as our normal VHDL code structure. Now if you observe here, test bench code structure is exactly as our normal VHDL code structure. So there is a library declaration, empty entity declaration, and same as the architecture declaration. Okay. Now after that we have to instantiate that design using this technique. So like we have done in the structural modeling, same here we have to instantiate it. Okay. So this is the instantiation name, my XOR is the that component, then port map. So here input 1, this input 1 of the XOR gate is connected to the internal signal input 1 underscore yes. So this we are going to connect. Okay. This is the entity signal. Then input T is again connected to the input internal signal input 2 yes, and output is also connected to output signal. So this is called the instantiation. So we have called the XOR gate and assign the signals. Now actually after that we have to start assigning the stimulus. Okay. So after that, once we have instantiated the component, then we have to start the begin. Okay. Okay, begin means this is after the process. So here we are going to use the process, and here there is a no sensitivity list. No sensitivity list means we are going to use the wait statement. So whenever we are going to wait statement, no need to declare any sensitivity list signals. Okay. So we are going to use the process. Okay. So because we have to assign the signal sequentially, then begin. So what are the test cases required for XOR gate? So we have to remember our test bench. So let us say input A, B, and output Y. So what are the conditions? Input 0, 0, 0, 1, 1, 0, 1, 1. Okay. So accordingly output will generate for the XOR gate 0, 1, 1, and 0. Okay. So this is expected. So whenever we have to generate a test bench, we have to remember our test cases. So that test cases only we are generating. So what we are doing, begin input signal 1, input signal yes, value we are assigning 0. So we are assigning input initially 0 and input 2 also 0, and wait for the 10 nanoseconds. So we have to wait for 10 nanoseconds. So after that, after this 10 nanosecond, output 1 underscore yes will become 0, and that value ultimately is going to the XOR gate output yes. So this value XOR gate, see how it works. So this input values then assigned to the input 1 of the XOR gate, then input T is assigned to the input 2 of the XOR gate. This is going to the input of our XOR gate, right? Sorry, XOR gate. Then this output is connected to output 1, and then this output is again connected to the output 1 yes, and in the test bench we can visualize immediately here yes, the output came 0. So like that we need to generate various test cases. So next test case is 0, 1, then 1, 0, and 1, 1. So whatever the values we are assigning in the waveform, that values only we have to generate here, and keep running this. So we can generate various conditions, various test cases, and it helps in one shot we can verify our design. It helps to verify our design very fastly, function very fast, and gives the result also whether it will pass or fail. So these are all the advantages of test benches. So in next lecture we are going to see combination circuit example, how to test the combination circuit using test bench. So thanks for the watching, keep watching videos.